Welcome to Inverses of Relations and Functions. Today's objectives are to learn how to graph and recognize inverses of relations and functions, and to find inverses of functions. One way to think about inverse functions is to consider them functions that undo each other. So it's helpful to look at an example of functions to think about the definition of inverse functions. So we say that inverse functions are functions that undo each other. So for example, if I have a function x plus 6 and I input the value of 3 in for x, I'll have 9. Now the inverse function would basically do this backwards. So instead of having an input of 3, I have an input of 9, and I do it into the inverse of this function. So if this function is some variable x plus 6, the inverse of that function will be x minus 6. So I'll say that my inverse function, and this is how we'll write inverse function. So this just means inverse function. So the inverse of my function f of x, instead of x plus 6, will just be x minus 6. And if my input is 9, and I put that into this function, my output will be 3. So we say that inverse functions are functions that undo each other, and this is kind of the idea, to figure out what the operation is and just do the opposite of it. So let's use some inverse operations to write the inverses of each function. Now, when we're writing the inverse to certain functions, we want to think about what's happening to the variable. So here, in this example, f of x equals 2x, the variable x is being multiplied by 2. So we know the inverse of multiplication is division. So in this first example, x is being multiplied by 2. So the inverse of that will be x being divided by 2. So once again, we want to think about what's happening to the variable and just do the inverse of it. So in this example, x is being divided by 3. So the opposite of that would be to multiply x by 3. So the inverse of x equals 3x. In this last problem here, we have x being added to the quantity 2 divided by 3. So the inverse of that would be x minus 2, 3. Once again, you want to think about what's happening to the variable and do the inverse of it. Sometimes we have to do multiple steps to a function in order to get the inverse. So the best way to do this is to break down what's happening to the variable. So the first thing that's happened to this variable is that it's getting divided by 4. The second thing that happens to it, 5 is subtracted from it. So for the inverse, we have to basically flip these and do the opposite of them. So the first thing that should happen to it is that we add 5 to it. And the second thing we should do, we should multiply by 4. So our inverse function with respect to x will be x plus 5 multiplied by 4. So let's try a practice problem now. So we know that x in this example, first thing that's happening to it is that's being multiplied by 5. Then we're subtracting 7. So if we flip that, we're going to add 7 and divide by 5. So we're going to take, and we're writing the inverse of this function, so we're going to take x, we're going to add 7 to it, and then we're going to divide the whole function by 5. And that'll be our inverse to it. So the trick is to figure out what's happening on the original function and then just reverse the order for the second part of it. In all these problems, we're looking at what's happening to the variable. Let's look at an example of writing and graphing an inverse function. So here we're going to graph the function 3x plus 6, and then we're going to write and graph the inverse. So first thing I want to do actually is I want to write the equation for the inverse. So let's write the inverse first. So in doing this is pretty simple. So we know that whenever we see f of x, that essentially means y. So we can rewrite this equation up here as y equals 3x plus 6. Now in order to write the inverse, we're still thinking about what's happening to the variable. So here we have y equals 3x plus 6. Now in order to write the inverse of an equation, all we do is switch the x and y. That's the first step. And the second step is we solve for y. So in this equation we have y equals 3x plus 6, but when we switch that we're going to have x equals 3y plus 6. Then that's the first step, switching x and y. Now we just solve for y. So we have x minus 6 equals 3y. And then when we solve for y, we're going to have y equals x divided by 3 minus 2. Now we can graph both of our functions. So I'll graph the original one in red and the new one in blue. So the original function has a y-intercept of 6 and a slope of 3 over 1. So we go up 3, 1, 2, 3 over 1, down 3, 1, 2, 3 over 1 as well. So here's my function, here's the line, and that's our first line. Now the second one has a y-intercept of negative 2 and a positive slope of up 1 over 3. Up 1 over 3. 1, 2, 3. Down 1 over 3. 1, 2, 3. So these functions are inverses of each other. You can think about this as being reflected also over the y equals x line. Now this graph isn't drawn perfectly, but this line here basically serves as the reflection of these two lines. Let's practice one more of these. So same deal, we're graphing the function 2 over 3 times x plus 2, and then we're going to write and graph the inverse. So the first thing I'll do is write the inverse. And I know the inverse, I have to just switch x and y. So my original is y equals 2 over 3 times x plus 2. This is my original. And I'll write my inverse. So I'll switch x and y and then just solve for y. So I'll subtract 2. I'm left with 2/3 y. and then I'll just multiply both sides by 3 over 2. So multiply this side by 3 over 2, and I'll multiply this side by 3 over 2. So then I have 3x divided by 2 minus 6 over 2 equals y. I simplify that out and I have y equals 3x over 2 minus 3. This will be my second equation. So I graph these, look at my first equation, y-intercept of plus 2, and the slope is up 2 over 3. 1, 2, 3. Down 2, 1, 2 over 3. 1, 2, 3. So that's my first line. And my second line has a y-intercept of negative 3 with a positive slope of up 3, 1, 2, 3 over 2. Down 3, 1, 2, 3 over 2. And those are my inverse functions. In the previous example, we were given a function and we had to switch the x and y's to find the inverse of it. Now here we're just given a relation, which is basically a set of data points, and we're doing the same thing. We're graphing the inverse of it, but the idea is still the same. If this is our original relation, to find the inverse of it, all we need to do is switch the x and y. Switch x and y. So what I'll do to show this is that I'll graph the relation first and then switch the x and y and graph the inverse. So for these set of data points, when x equals 0, y equals 2. When x equals 1, y equals 4. When x equals 2, y equals 5. When x equals 4, y equals 6. And when x equals 8, y equals 7. So we have this kind of curving relation here. So to find the inverse, all we do is take these values and switch the x and y. So I'm going to just create a table. I think it's easier to see it. So instead of x being 0, now x is 2 and y is 0. And then we go on and just switch all of these values. Now x is 4, y is 1, x is 5, y is 2, and I'll just make it in the table here to finish. Now x is 6, and y is 4, and x is 7, y is 8. So let me graph these now. So when x equals 2, y equals 0. When x equals 4, y equals 1. When x equals 5, y equals 2. When x equals 6, y equals 4. And when x equals 7, y equals 8. So you see that there are the inverses of each other. And once again, this line of y equals x is basically their point of reflection. This is y equals x. We can also find inverses of formulas to help us solve for different values in the formula. So the formula C equals F divided by 9 times F minus 32 gives degrees Celsius as a function of degrees Fahrenheit. So let's find the inverse of this function to convert degrees Celsius into Fahrenheit and use it to find 16 degrees Celsius into 16 degrees Fahrenheit. So, similar to the other functions we're working with, we're basically switching the variables and solving for the other one. So originally this function is set to solve for C. So our goal is to solve for Fahrenheit. Now since f is being subtracted by 32 and multiplied by 5 over 9, we actually want to isolate f. So basically we're just solving for f here. So we have our equation C equals 5 over 9 times f minus 32. So our goal is to solve this equation for f. So first thing we'll do, multiply both sides by 9/5. Then we have 9/5 times c equals f minus 32. Then we just add 32 to both sides. So we have f equals 9/5 times c plus 32. So that was the first part of this problem, was to find the inverse, and now we're going to use it to plug in 16 degrees Celsius to figure out what it is in Fahrenheit. So we just plug in 16 for c. We have 9 divided by 5 times 16 plus 32. And 9 times 16 is 144, divided by 5 plus 32, which comes out to roughly 61 degrees Fahrenheit. That's the end of our video. I hope this was helpful. If you want to go back, pause it, do some of the problems over, you're more than welcome to. Alright, thank you. Take care.